All right, we're going to finish up this section, and we've been talking about polar coordinates and Cartesian rectangular coordinates. In the last video, we went from Cartesian into polar. Now we're going to go the other way, and it's not as easy. I don't think you're going to find it terribly difficult, but it's not quite as intuitive as the other way. We're still going to rely on the same two skills, or the same two tools, perhaps I should say. We're going to rely on these. Sine of theta, sorry. Now we're going to change this a little bit. What we're going to do here is we're going to go back to this definition so that we're going to replace sine and cosine with x over r and y over r. So that's going to allow us to get a little bit, this will allow us to get theta out of the story and at least get something that's polar. It won't get us all the way there, but it'll get us part of the way there. So let's get started here. So our first one, we're going to take a look at the idea that secant is of course 1 over cosine. So let's make that change. We're going to turn this into 2 over cosine of theta. Now, if I move cosine of theta up to the top over here, I get r cosine of theta. So this is by definition x, and so x is 2. I just said we wouldn't be using these, but we're using it here, so I guess they're all fair game. So r cosine of theta, that's x, and so we've done it. R equals 2 secant of theta turns into just x equals 2. And so remember that that's a vertical line at x equals 2. Okay, now here's a more complicated one. What we're going to do here is we are going to start by changing this. Cosine of theta is going to be x over r. So we've made that change here. They did it in kind of 2 steps. So cosine of theta is going to be x over r, which allows us to get rid of theta. Okay, so now we've got r, so we're partly there. We're going to need to worry about this x. We've got to, well, actually, I guess we wanted x. I'm sorry, we're trying to get to Cartesian. So we wanted x, but we need to get rid of r. So anyway, this is 1 minus 2 cosine, or 2xr. We're going to multiply that up to the other side. That's how we got here. Now this may not seem real clear, but look at what we're doing here. This is what they're really doing in this step. So what they're going to do is get a common denominator here. This is going to be r times r minus 2x all over r. Now, this r and this r will cancel. So they went very quickly, but this algebraically can just turn into this. Now we have r minus 2x equals 3. Okay, well we're on our way. We need to just get rid of the r now. So let's send the 2x to the other side. We get down to here. R is 3 plus 2x. So that's pretty good. Now, how are we going to get rid of r? Well, this is the best way we can do it. The way to get rid of r is that r squared is x squared plus y squared. So let's square both sides. That'll create r squared. See what we've done here? Now, r squared can be replaced with x squared plus y squared, and we've done it. Now, this is not a very nice, attractive formula, but it is Cartesian now. It is rectangular. Now they went ahead and down here went ahead and finished it all the way for y. I wouldn't require that you do that. If you can get this, that's good enough for me. This is much harder, but you could keep going with it, and that's how they got down to here. So you see these formulas we're making are not simple. They're not intuitive. So here's what these two graphs look like. Quite complicated. Okay. Now, let's make another change here. Let's try to go, we're trying to get this, so we get rid of theta and r, and we want all x's and y's. So what I'm going to try to do here is that sine of theta is y over r. Okay? So that's, remember we have y equals r sine of theta is one of our definitions, so we could just, main sine of theta is just y over r. So I'm going to swing this r up, and I'm going to get r squared is now 2y. Say, wait a minute, r squared, that's what I want. I want to get rid of the r's, and we know r squared is the same as x squared plus y squared, and we're done. Now, this is a circle, and there's a lot more you could do to make it nice and pretty, but for me, that would be good enough. All right, let's do it again here. Now, here's the problem. We have a double angle in here. So we're going to need, we don't have any of our definitions don't include, any of our tricks don't include a double angle. So what we're going to do here is we're going to use the double angle identity. So sine of 2 theta turns into this, r sine of theta cosine of theta. Now, how does that benefit us? So we no longer have that double angle, and we know we have definitions for cosine of theta and sine of theta. We just made that substitution. Nice simple substitution there. Now, multiply this together, we get down to this line. Now this one is a little strange. Let's move r squared up, and this is now r to the third equals 2xy. Now we're almost there if we could just get rid of r to the third. Well, look what they're doing here. We know that r would have to be the square root of x squared plus y squared. You follow this? X squared plus y squared is r squared. So r must be the square root of that. So again, it's just the Pythagorean theorem. That's all it is. So they've replaced r with the square root of x squared plus y squared. Now there's three of them. It's cubed, and it equals 2xy. Now again, there's some fancy movements you could do, but if you get this far for me, that's good enough. You've gotten rid of all the thetas and r's, and I would take it. It could be recreated in this form, but it's not necessary. Okay, I thought there would be more of those, but again, not a ton of examples here, but we're using those same tricks going the other way. It's a little bit harder to go from this polar form to this Cartesian form. The tricks are not quite as intuitive, but it's not horrible. So hopefully that made some sense, and I can give you some supplemental illustrations if necessary.